Okay, I hope you tried these last three examples, and if not, you might try them, and we're going to go over them now. So, right here we have the equations y equals the square root of 4 minus x, and if you weren't sure which one of these that was, you could graph that using Desmos. And then you have y equals negative 2 minus x. So what kind of equation is that right there? Linear. So can you tell which one of these that is? It's going to be the line. So here you have, this one is y equals negative 2 minus x, has a y-intercept of negative 2, has a slope of negative 1, right? And then this is your radical function. This is right here, the y equals the square root of 4 minus x. It's important to know that because when you get to solving the inequality, you're going to want to know which one is greater and which one is less than. So we have our point of intersection is just that ordered pair. Well, who can tell me what's the point of intersection? Negative 5, 3. And then, so we use that as an ordered pair. That's not an interval. Now, if we want to solve this, we just want the x value. So our solution is going to be just the negative 5 is where they're equal. If you plug negative 5 in, you will get 3 on both sides for the y value, right? Once you plug an x value in, you get a y value. And that's how you would check it. Some of you, I was really impressed because some of you were going about solving this algebraically. So you were taking 4 minus x equals negative 2 minus x, and you were squaring both sides. So this would be the difference between solving it graphically versus solving it algebraically. When you square this side, you get 4 minus x equals, over here, when you square this side, you have to FOIL it out. So you would have to get, sometimes you might write it like this, negative x minus 2 squared is equal to negative x minus 2 times negative x minus 2. And it's not asking you to solve it algebraically. I just thought, since some of you were doing that, it would be kind of fun to go over. So when you square that, you get x squared minus plus 4x plus 4 when you FOIL it out. So you have plus 4x plus 4, and then you could subtract 4 from both sides, add x to both sides, and you get 0 equals x squared. Why am I setting it equal to 0? Yeah, because it's a parabola, it's a quadratic, and I want to solve for x. What would you do to solve for x from here? Factor. So you get x equals 0 and x equals negative 5. Well, you can see that we get the negative 5, but you can kind of see why we got x equals 0, but x equals 0 is not a solution, because what happens when you solve these algebraically is sometimes you get extra solutions, we call them extraneous solutions, that don't necessarily work, which is the reason why we have to check. So anyway, I just wanted to kind of show you that connection between the two. So this is solving it graphically, is just looking at the graph. Now here we want to know, when is the radical greater than the line? So if we're thinking about y values, the y values are negative, negative. When is the radical above the line? And that's over here. So what interval, and actually I didn't even include all of it, right? That too. What interval would you put from, yes, say it. So isn't this from negative 5? Negative 5 to 4. And would we include the negative 5? No, because that's where they're exactly equal, so we're putting parentheses. Would you want to include the 4? And why would we include the 4? Yeah, so all of these points would make this greater, and then this stops right at 4. There's no open circle there. So that's why we're not going to infinity, because our radical function does not continue till it stops at, I mean, if you were to actually even talk about the domain of that radical function, which that's a little bit of a review from before too, what is the domain? You can see it on the graph, right? And you would solve, when is this greater than or equal to 0? So if you go 4 minus x, when is that greater than or equal to 0? Minus 4, negative x is greater than or equal to negative 4. Divide by negative 1, sorry. And you get x is less than or equal to 4. So that's just kind of a review of the domain of a radical function, but you can see it on the graph as well. So that's why we're stopping at positive 4 here, and we're including that point. Okay, let's look at example 7, and I would encourage you, if you haven't had a chance to try it, go ahead and try it, and then continue. So we want to first find the points of intersection. We have our parabola, so we have here is s of x, and we have our line, t of x. The points of intersection are negative 10, 50, and 15, 25. And these are x values, so I wouldn't use any kind of these are not intervals, right? These are, they're ordered pairs. Now, if we want to solve where it's equal, remember that we're finding the x values, and so here, what would you say the solution is? It would be negative 10 and 15, because these are two x values where we're seeing that the graphs are equal to each other. And of course, you could always set these two equal to each other and solve algebraically. That's a totally different topic that we've done before. Now we want to know, when is s of x greater than t of x? Since here we have t of x and here's s of x, we're looking for what is this interval here and here? So we go down to the x values, and who can tell me the different intervals for the solution to that inequality? You'd have, go ahead, what is it? Negative infinity, right? To what? To negative 10. Should I include the negative 10? Because of the greater than, not equal to. Union, and what's the next interval? Yes, 15 to infinity. Thank you. Okay, and now here this is saying, when is s of x less than or equal to t of x? So since this is s of x, here's t of x. Our less than area is underneath the line, is when s of x is less than t of x, less than or equal to. So what's that interval? Negative 10 to 15. And should I just write it like that? That's good enough? Oh, with brackets. Why brackets? Yes, less than or equal to, so we're including those endpoints. Any questions about that? Okay, and then here's the last one, last problem of the term. So here you get to use your Desmos. So let's go ahead, I'm going to pull up my Desmos. And I already have my two graphs drawn. And we're not going to scale this, we're just going to kind of draw a sketch of the graph. And so you have your points of intersection. Points of intersection are negative 1.2, is this what you got? Negative 5.4, and 1, and negative 12. These are the points of intersection between the lines. So you have the parabola that opens downwards, so maybe you drew something like this. And then you have the line, which you have a slope of negative 3, y-intercept of negative 12. So maybe you drew something along this line. And here are my points of intersection, right? So we're not looking for the intercepts or the vertex or any of that. We're really just looking for, where does the line cross the parabola? Okay, and so once from those points of intersection, mine might look slightly different just depending on the scale, like how much did you zoom in and out. Hopefully the shapes look essentially the same. And I'll have to look at yours then to see why it might look different. Okay, and then if we want to solve, where are they equal? Who can tell me that? Where are they equal? What did you get? Negative 1.2 and 1. Because again, we want the x values. That's where they're going to be equal to each other. And then where is f of x greater than g of x? Well, f of x is my parabola, and g of x is my line. So where is the parabola greater than the line? Greater than would be all the way up here. So what did you say for greater than? Right? From negative 1.2 to 1. I'm not including those endpoints. And then where is it less than? Where is the parabola less than the line? So that could be down here and down here. And so what would we say? From negative infinity till negative 1.2. Why did I include the endpoint there? Because of the equal to union 1 to infinity. Is that what you got? Any questions on any of that? All right, great job, team.